In this video, we will solve further problems from exercise 3.5. Question number 7. Prove that 1 plus tan 1 degree into 1 plus tan 2 degree into 1 plus tan 3 degree and so on up to 1 plus tan 44 degrees is a multiple of 4. Right, so let's take the last expression first. So 1 plus tan 44 degrees can be written as 1 plus tan 45 degrees minus 1. So, further, this is like tan A minus B. So, applying the formula, this becomes tan 45 degrees minus tan 1 degree divided by 1 plus tan 45 degrees and tan 1 degree. Further, let's put the values of tan 45 and tan 45 here. So this becomes 1 plus 1 within bracket. This is minus tan 1 degree divided by 1 minus 1 into tan 1 degree. So this is 1 plus tan 1 degree. Further, simplifying this, keeping 1 plus tan 1 degree as a denominator, the numerator will be 1 plus tan 1 degree plus 1 minus tan 1 degree. Further, simplifying this, the tan 1 and plus and minus will become cancelled. This is 2 by 1 plus tan 1 degrees, which is on the left hand side we have 1 plus tan 44 degrees. So cross multiplying this to the left hand side, this will become 1 plus tan 44 degrees into 1 plus tan 1 degree is equal to 2. Similarly, we can prove 1 plus tan 43 degrees into 1 plus tan 2 degrees is equal to 2, and so on up to, we can go on up to 1 plus 23 degrees into 1 plus tan 22 degrees equal to 2. Now, if we multiply all these terms on the left hand side, so let's start with 1 plus tan 1 degree, 1 plus tan 2 degree. So you will have 22 terms all the way to 22, and then we can multiply also with the remaining terms, which is 1 plus tan 23 degrees and everything. So let's put them together. So 1 plus tan 1 degree. So let's start with the right side terms. 1 plus tan 2 degrees, and it will go on 1 plus tan 22 degrees, and then you have this 1 plus tan 23 degrees, and go on all the way till 1 plus tan 44 degrees. So you can clearly see there are 22 terms here, 1, 2, and all the way to 22. So on the right side you should have 2 times 22. So this is 2 into 2, so on up to 22 times. So clearly the given expression is a multiple of 4. Hence the proof. Question number 8. Prove that tan pi by 4 plus theta minus tan pi by 4 minus theta is equal to 2 tan 2 theta. So let's take the first term, which is tan pi by 4 plus theta, and let's expand it like tan A plus B. So this is equal to tan pi by 4 plus tan theta divided by 1 minus tan pi by 4 into tan theta. Tan pi by 4 is 1. So this is equal to 1 plus tan theta divided by 1 minus tan theta. Similarly, our tan pi by 4 minus theta will be equal to 1 minus tan theta divided by 1 plus tan theta. Therefore, our left hand side is equal to tan pi by 4 plus theta minus tan pi by 4 minus theta will be equal to 1 plus tan theta divided by 1 minus tan theta minus 1 minus tan theta divided by 1 plus tan theta. So now taking the denominator as a minus b into a plus b, and multiplying these two, you will get 1 minus tan squared theta, and then cross multiplying, you would get this as 1 plus tan theta the whole square minus 1 minus tan theta the whole square. So further solving this, expanding this expression here, you would get 1 plus tan squared theta plus 2 tan theta, and expanding this expression and multiplying with minus, you will get minus 1 minus tan squared theta, and inside the bracket will be minus 2 tan theta, minus into minus will be plus. So plus 2 tan theta divided by whole thing divided by 1 minus tan squared theta. Now the 1 and 1 will be cancelled. Tan squared theta will get cancelled. So you're left with 4 tan theta divided by 1 minus tan squared theta. So you can rearrange this as 2 times 2 tan theta divided by 1 minus tan squared theta. Now 2 tan theta by 1 minus tan squared theta is nothing but tan 2 theta. So this is equal to 2 times tan 2 theta. That's equal to the right hand side. Hence the proof. Question number 9. Show that cot 7.5 degrees is equal to root 2 plus root 3 plus root 4 plus root 6. So let's take the left hand side, which is cot 7.5 degrees can be rewritten as cos 7.5 degrees divided by sine 7.5 degrees. Okay. Now let theta be equal to 7.5 degrees, and therefore we can rewrite our expression as cos theta by sine theta. Now let's multiply the numerator and denominator by 2 times cos theta, 2 times cos theta. So this becomes 2 cos squared theta divided by 2 times sine theta cos theta. Now this is the numerator will be 2 cos squared theta can be rewritten as 1 plus cos 2 theta divided by, and the denominator is in the form of sine 2 theta. Okay, so these are the double angle identities that we have used here. So 2 theta will be nothing but 7.5 into 2, which is 15 degrees. So therefore we can rewrite our cot 7.5 degrees, which is equal to cos 7.5 divided by sine 7.5 degrees will be now equal to 1 plus cos 15 degrees divided by sine 15 degrees. Okay, now let's find the values of cos 15 degrees. We can rewrite this as cos 45 degrees minus 30 degrees, which is equal to cos 45 cos 30 plus sine 45 sine 30 degrees. So substituting the values, this is 1 by root 2 into root 3 by 2 plus 1 by root 2 into 1 by 2. You get the value as root 3 plus 1 divided by 2 root 2. Similarly, our sine 15 degrees will be equal to root 3 minus 1 divided by 2 times 2 root 2 using the same method. So applying that here, you have 1 plus root 3 plus 1 divided by 2 root 2 in the numerator divided by the denominator. You have root 3 minus 1 divided by 2 root 2. Now in the numerator, let's take 2 root 2 as a common. So let me write it here. So you have 2 root 2 as a common denominator for the numerator. So the numerator will come 2 root 2 plus root 3 plus 1 divided by root 3 minus 1 divided by 2 root 2. So the 2 root 2 and 2 root 2 will disappear. So you're left with 2 root 2 plus root 3 plus 1 divided by root 3 minus 1. Now let us multiply the numerator and denominator with root 3 plus 1. So root 3 plus 1 divided by root 3 plus 1. So this is multiplying and dividing by root 3 plus 1. Okay, so now your denominator will become a minus b into a plus b. So it is a squared minus b squared. So root 3 squared is 3. 3 minus 1. And your numerator will now become 2 root 2 plus root 3 plus 1 multiplied by root 3 plus 1. Okay, so now let's multiply the numerator and remove the bracket. So this will be 2 root 2 into root 3 will become root 2 into root 3 is root 6. So 2 root 6. 2 root 6. Then let's do root 2. 2 root 2 into 1. So plus 2 root 2. Then let's take root 3 and multiply with the first term, root 3 here. So root 3 into root 3 will become 3. So plus 3 root 3 into 1 plus root 3. Then 1 into root 3, again plus root 3. Then 1 into 1 plus 1 divided by, our 3 minus 1 will be 2. So this left hand side now becomes, our term now becomes, there are 2 root 3's. So let's take the common terms. So it's 2 times root 6 plus 2 times root 3. Then you have 2 root 2 plus 2 times root 2 plus you have plus 3 plus 1 is 4 divided by 2. So let's take the 2 out now. If you take 2 out, you will be left with root 6 plus root 3 plus root 2 plus 2 divided by 2. So let's cancel these 2 and 2. Now let's replace 2 with a root 4. So if you rewrite this, then this becomes root 2 plus root 3, and this 2 will become root 4. Root 4 plus the root 6. This is equal to the right hand side. Therefore, LHS is equal to RHS. Question number 10. Prove that 1 plus secant 2 theta times 1 plus secant 4 theta and so on up to 1 plus secant 2 power n theta is equal to tan 2 power n theta into cot theta. So let's take the first expression from here, which is 1 plus secant 2 theta. And let's rewrite this as 1 plus secant theta is 1 by cos theta. So this is be 1 by cos 2 theta. Again, taking the cos 2 theta as the LCM, this becomes cos 2 theta and cos 2 theta plus 1. Now cos 2 theta plus 1 is nothing but 2 times cos squared theta divided by, we have cos 2 theta in the denominator. Now let's take the second expression, which is 1 plus secant 2 theta. This can be again rewritten as 1 by this is 4 theta. So this becomes 1 by cos 4 theta. Again, taking LCM, cos 4 theta, then the numerator will become cos 4 theta plus 1. This can be again rewritten as 2 times of cos squared 2 theta divided by cos 4 theta. So if we continue all the way to 1 plus secant 2 power n theta, what we would get is 1 by cos 2 power n theta, and that will be equal to cos 2 power n theta cos 2 power n theta plus 1, and that would be nothing but 2 times cos squared 2 power n minus 1 theta divided by cos to the power 2 power n theta. Now if we multiply all the left hand side terms, so let's say LHS is equal to 1 plus secant 2 theta into 1 plus secant 4 theta 1 plus secant 2 power n theta will be equal to the right hand side. Let's put all the right hand side terms. 2 cos squared theta divided by cos 2 theta into 2 times cos squared 2 theta divided by cos 4 theta, so on up to 2 times cos squared 2 power n minus 1 theta divided by cos 2 power n theta. So if we take the right hand side, here our cos 2 theta will get cancelled with this square term here. So this square will become cos 2 theta and this cos 2 theta will disappear. Similarly, this cos 4 theta will also disappear with the consecutive term, and this cos to the power cos squared 2 power n minus 1 theta will again be of 1 power. So this will be cos 2 to the power n minus 1 theta. So what you're going to be left with is 2, and this cos squared theta, I'm going to break it into 2 cos theta, okay, and I will leave the other cos theta, and I'll bring this cos 2 power n theta here, cos 2 power n theta, and within bracket we will have cos theta into cos 2 theta, so on up to cos 2 power n minus 1 theta, and this 2 will become 2 to the power n because it will be n times. Right. Now, this expression, which is cos theta into cos 2 theta and so on up to cos 2 power n minus 1 theta, is equal to sine 2 power n theta divided by 2 power n into sine theta. This is from example 3.32 in the book. Now, let's replace this value into this. 2 power n cos theta divided by cos 2 power n theta into sine 2 power n theta divided by 2 power n into sine theta. Okay, so 2 power n will disappear. So sine 2 power n, so let's rewrite this as sine 2 power n theta divided by cos 2 power n theta into cos theta divided by sine theta. That's equal to, this is tan 2 power n theta 2 power n into cos by sine is cot theta. That's equal to our right hand side, hence the proof. Question number 11. Prove that 32 into root 3 sine pi by 48 cos pi by 48 cos pi by 24 cos pi by 12 cos pi by 6 is equal to 3. Let's first take the first 4 terms here. So 32 root 3 into sine pi by 48 into cos pi by 48. Let's rewrite this with multiplying, or expressing 32 as 16 times 2. So 16 root 3, taking the 2 to the other side, this becomes 2 times sine pi by 48 cos pi by 48. Now this is in the form 2 sine theta by 2 cos theta by 2. So we can rewrite this as 2 sine theta. So if theta by 2 is equal to pi by 48, then theta will be equal to pi by 24. Therefore, this we can rewrite this as 16 root 3 into sine pi by 24. Now let's take this term and multiply it with the next term here. So 16 root 3 sine pi by 24, which is from here, let me call this as 1. Okay, and multiply this with the second term, which is cos pi by 24. You can already notice they are following the same pattern. So let's follow the same method that we did for the previous. Break 16 as 8 root 3 and move the 2 inside and say this is sine pi by 24 cos pi by 24. That would be equal to 8 root 3, and this will become sine pi by 12. Okay, now our theta by 2 will be pi by 24, so theta would be pi by 12. Now let's call this 2 and multiply this term with the next term here. So this becomes 8 root 3 sine pi by 12 into cos pi by 12. Again, they're following the same pattern. So this will be 4 root 3 into 2 times sine pi by 12 cos pi by 12 is equal to 4 root 3 into sine pi by 6. Let's call this 3. Next, let's multiply 3 with the last term here. So 4 root 3 sine pi by 6 into cos pi by 6 is equal to 2 times root 3 into 2 times sine pi by 6 cos pi by 6. So this will be equal to 2 root 3 and this will become sine pi by 3. Let's call this 4. Therefore, from 1, 2, 3 and 4, we can say 32, which is the LHS, is equal to 32 into root 3 into sine pi by 48 cos pi by 48 cos pi by 24 cos pi by 12 cos pi by 6 is equal to 2 times root 3 sine pi by 3. And sine pi by 3 is nothing but root 3 by 2. So this becomes 2 root 3 into root 3 by 2. So 2 and 2 will become cancelled. Root 3 into root 3 will be 3. Therefore, this is equal to RHS. Hence the proof. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.